Oh, hello. I'm back here. Let's just start this, guys. A little sleep deprived today, but I'll do my best. I'm gonna be a little bit slow. But let's get to the part 2 of this tutorial. So let me open Houdini here. I hope you guys are able to listen to me. Please give me feedback if not. If you're seeing the screen moving and everything and unable to see, please let me know. Alright. So what we did in the last part of the tutorial, the first part, we ended up creating this block out, right? Basically, the idea was getting the shapes and forms however we wanted, right? And how it was a little bit more performant to actually do the low poly. And we had the concept as the image here somewhere. So I'm gonna try to actually get this image here for us. 1 second. Let me know, where did I put? 1 second. Right here. Perfect. So yeah, this is the reference that I got for the first part, and so we were able to do the swirl parts, the top over here and the bottom. And if you watch the first video, you're gonna have the idea of how I actually approach this. And we're gonna get to the next part, which is I want to make sure that we have the lines over here, the curves. And actually, one of the things that, thank you, actually, Evening, you requested about making sure that he made a question here. Let me read for you guys to understand. He said, some practical demo advice on curved tangents when modeling would be great if you get a chance, or duplicating along a curve and controlling the rotation on objects in different ways. So let's I'll help you with that, Evening, at first, because I believe it's a really cool thing that we can do. So I'm gonna go back here. I'm gonna create another one, another geo on the side, so we kind of have like something a little bit separate. So I'm gonna do like curve tangent. Okay, let me just do this because I don't want to show the other objects. So I'm gonna create a curve right here, just so we can play. I actually don't know the solution yet, but I may be able to find it real quick. So I'm gonna just create any sort of curve, right? And I wanna do just move some points here and there, just so we can have height and, you know, any sort of I want to make sure that the curve has some sort of depth as well, so we are able to actually see the tangents and how it works. So I'm gonna do that. Boom. Alright, that seems okay. Alright, so as you guys can see, it's not like, it's entirely in 3D, it's not 2D, right? So I'm gonna put over here resample, and in this resample, I want to make sure that I have points in the middle, but at the same time I want this to be subdivision or interpolating. Up to you. You choose however if it makes it best for the curve to actually do the job that you want. So now that we have this, so we can see that as soon as we press this button over here on the display normals, it doesn't show anything, right? Because we don't have any normals on the curve. So what I want to do here, there's a polyframe node, and this polyframe is going to cause to bring some normals to it. But as soon as we put the polyframe, I'm going to leave as default right here. I'm not going to touch it right now. I'm going to go here to the curve, okay? And as soon as I move this, you can see that what it's doing is normalizing the angle of overall entirely to the curve, because honestly, it doesn't know from the tangent name right here, it doesn't know where exactly is the direction they want the bitangent, the normal, and the tangent. So what I usually do is I'm going to press N over here on the tangent. I'm going to put up on the normal. So you can see now that the normals, actually I'm going to decrease the size of the normals over here. 1 second. So you can see that I have the tangency of all of the curve, like the entire thing is actually bringing the normal to the tangent, because I'm putting this as N. If I change this to not be up, you're not going to see it because the up function, it's not there, it doesn't show. So what we can do here is we can add, I'm actually add it as a comment over here so we can see. I'm gonna put as a marker, okay? I'm gonna call this up marker, I guess. And then I'm gonna make sure this attribute has up right here. And I do not want text, okay? I will want a vector. So you can see now that up itself, it's bringing the vector of up, which is down right now, or up, actually it's up, sorry. Yeah, it's actually down because what happens is it's still normalizing through the whole thing. It doesn't really give you what we were looking for. So you can do that on the binormal, I'm sorry, and that will give you what we were looking for, as if you would do a cross product on the normals themselves. I prefer using the normal. Oh, you're welcome, man. No worries. So yeah, I slept like maybe 2 hours, but I actually don't mind. I'm used to that. So what we want to do is actually bring whatever the up is doing, the bitangent over here, to be the normal itself. The problem is, if we do this and I take off the tangent, right? It may work, but we don't necessarily know what direction it's going. You can even see here that it kind of brings some sort of weird, it doesn't give us a direction specifically. So what we're going to bring back to the tangent, okay? And I'm going to leave the up on for now. We can do the up actually in a different way. We can, I'm going to put a point over here. We actually want the up sometimes because we want to make sure where the world is, right? And if you don't have a direction of the world, you're not going to be able to know what you're going to do with the normals themselves, because it's a vector. So I'm going to put up right here as a custom, okay? And I want to make sure that it's a value. And the value can be 1 on the y. So you can see now the up is there, which is awesome. Okay. So right now I do not want to see the up. I'm just going to leave it here for now. And we can do a cross product over here. So I'm going to do a pop. A point pop. Again, I'm not sure if I'm doing the way people would do. There's probably plenty of ways of doing this, but I'm gonna do a cross product, okay? And I'm gonna bring the normal in the vector 1, and we know that the 1 is y over here. And as soon as I do this, it will get us the same result as what the bitangent was doing before, right? It's a little bit different because honestly, it's getting the other way. So if you go back there, let's just check. I'm gonna take this off. I'm gonna put just the bitangent. If we do this here, in comparison to whatever we have here, it is just simply the opposite side. But that's not bad. That's actually a good thing. So as soon as I do the first edge, it only will normalize in between the one edge only, right? And then we want the 2 edges. The only problem is, since we have, let's just say I have here, I'm gonna show without the resample. So you can see that I have those points, right? And we don't necessarily know where the direction of the curve is going through. Like it can change at any time or rotate however we want, right? So if I do this, let's just say I move this point right here, right? And I keep moving, keep playing around with the curve. For now, it's fine. But you can see, for example, right here in this spot, you can see that it's not necessarily averaging, right? And there is math that we can do and make sure that we have that correctly, but I'm not going to go that route because we're going to take a long time here to just explain what it will do with the tangents. And there's an equation that you can use, but it's more complicated than doing right now. It's not necessarily so exact as well. So what I would do for this, I would just do a blur right here and put it as the normal, and I will not pinpoint the borders. So this way you're going to have a little bit of an averaging through those sections. What you can also do is, let's just say I have a measure. I'm going to put a measure node. And in this measure node, I'm going to choose to be points, and I want curvature. We can do, I think this seems to be fine. So I'm going to use this curvature, and I'm going to put this remap range right here, and put this function on the weight attribute. So as soon as I do that, it will try to average a little bit better, but the curvature itself, it has to be, I think it's mean or Gaussian. I have to find which one we want to use for this. Or maybe I have to put as a higher value or -1 here. Let me see. Or maybe maybe I cannot do the baking. I don't necessarily remember the how I did it before, but I remember fixing this before. Come on, Hugo. What's going on here? I think I have to bake. Put -0.5, 0.5. Okay. So it is doing the blur, but it's kind of causing some issues here and there. But it gets a little bit better, yeah. So basically what is happening is the measure over here, if I do a CD, which is just the color, you will see that only the white spots on the points are going to kind of do the job of the normals to be averaging, because we don't necessarily want everywhere. We only want where it's actually doing the sharpened parts. You can also use the volume preserving. Sometimes it works better. And oh yeah, actually I would use the edge length because we actually want this to be 0.1. Let me check. Because it's actually, yeah, it's a positive. I forgot about that. So the edge length over here, and you just put a 1 over there, and it should be better to actually see the normals a little bit more, you know, it gives a little better approach of how the tangency of the normal work. Another approach will be, if you want, you can, let's go out, just bring this guy here. You can do a resample. Okay. Let's do this. And in this resample, I'm gonna put less points. So I'm gonna put perhaps 1 over here. Okay. And I want this to be subdivision, or it can be interpolating as well, but I think it's, for this reason, it's better subdivision. So as soon as I do this, I want to bring this curve, the normals that are there over here, right, to whatever it's here. So let's try, let me try it without it just to see if I can get it. No, I will not do that. Okay, so we have to have, unfortunately, have to have the subdivision curves. And what we can do, let me see. 1 second. Yeah, so let's just do it this way. We can do, there's plenty of ways that we can get the information of this curve to the other one. What I would do, let's see, we have transfer attribute transfer, sorry. And we can bring to this curve the normals over there. How we do it, we just press N over here. And it should have like a condition over here. So let's just see if I am able to get it. So you can see now that because of the amount of samples that I'm doing, right, and the distance of the kernel, if I show the other curve, let me put the background as black over here so we can see better. Dark, yep. So you can see now that the curve over here is actually causing the tangency over there to, you know, normalize. What you can also do is, let's just say I create a ray, right? And in this ray, I'm gonna bring this guy right here and that guy right there, because I want to set up in a way that the minimum distance, it's gonna select the other curve. Actually, the opposite. No, it's actually correct. Sorry. And what happens is, now that I have this transformation, right, I'm able to use this as the possibility of getting the blend. So I'm gonna do a blend shapes right here, and then get that guy there. I believe that's it. So you can see now it's using, but the attribute that I want is just position to do. I don't want the normals to be changed, but unfortunately it is. I don't know why. Let me see. It's not supposed to. Interesting. It actually is changing the normal right there. I don't want this to happen. Let me see here. Yeah, I don't remember necessarily how to make this one work, but I don't even know if it was the blend shapes. I think there was another one that was, let me see, attribute. I think it's a attribute composite, I believe. I remember there was another way of doing this. I think by point as well. You can do by point, and there's like a copy. Let me see the functions here. Yeah, so if you use second input, not the p, right, which is the n itself. So let's try it this way. So we're gonna bring that curve, which is this gentleman, and we know that we want the normals of that guy. Let's see if that transfers better. And normal. Let's see if this works. Yeah, it's not averaging so well. It's like not bringing the information that we want correctly. So I would avoid doing this way right now because I don't remember how I did it. So anyway, let's go back to what you actually wanted, evening. Let's bring this UI a little further. All right. So now we know that we have the curve, we have the normals as cross product, right? So I'm gonna delete this guys because we won't need it. And in this curve, we you mentioned you wanted duplicate a long curve. So let's just say I'm gonna create a box right here, right? And this box, I'm gonna do a copy, copy transform, no, copy to points. I would avoid, guys, using copy stamp. It's so heavy. If you're like start adding functions and stamps over there, it's gonna take a long time, especially if you do like a for each loop on top of it. Oh my god, it takes forever. It's insane. So I would avoid that, and I will use copy to points. So let's just say I have the points here, right? And I'm gonna copy the boxes. And again, now it is using the transformation of the tangency, right? Like you can see that the boxes are rotating the way I wanted to. The problem is, as you noticed, the up, right, of the world is 1. And we don't necessarily want the up to the world. So you actually want the whole thing to actually follow through without giving an issue. How we're going to be able to manage that? Let me think about this because long time I don't do this. Let's see. So I want to know the up, but I want the binormal as well. So I'm gonna use the up as the thing here. So let me take this function off. So now we have the binormal, okay, and we have the cross product of the normal, but it's not necessarily doing what I really wanted. Let me try the normal. Okay, there you go. So now we're having the 90 degrees of what we were looking for, which is good. So this way, whenever I bring the boxes, it's going to follow a little bit better what is intended, but it's not entirely. I can't remember exactly how I treated this before. Let me think. Oh yeah, I think I have to go back to the point right here. And let me do this here. Put this guy here. This is polygon. Actually, I'm gonna use the curve attribute. I'm just gonna leave it right here on because later on we're gonna use it. And let me see if I do this way. And I don't want the up right here. I'm gonna take that off. And since I have this, I'm gonna do another cross product right here. And you don't have to call like up. You can call tangent, for example. It doesn't matter. It's just that up is what I usually use for up in the world, but it's better actually to call it tangent. Again, it's good to see that there are a lot of options. That was a hell of a deep dive. I'm just into about 4 months of Houdini, so there's a lot of I know it's complicated because honestly you're really playing with the math of the vectors right there, right? A lot of softwares don't show you how to go around it. I mean, they already have a solution for you. You don't have to think about it, right? And it's good for us to actually understand how trigonometry works, and Houdini you will need that for sure. If you want to go crazy about it, you will need a lot of information about that. So let's do this. I want to create another function here. I'm gonna make sure that it's not up. I'm gonna call it tangent. And I'm gonna call this tangent, okay? And I want to make sure it is vector. Let me see. Yeah. And let's do tangent. And I'm gonna put another color here. So we choose. I'm gonna put it as red. All right. So now I am able to create over here bind export. Oh, sorry for the noise. The bike is actually going around. And I want this to be called tangent. And make sure that you put this as vector. Don't leave it as float or it's not gonna work. And as soon as I do this, you will see that the point red over there is doing the cross product for us. And if I put this on the normal itself, this is doing what the tangent was doing, which is what we wanted, right? But now I want the vector that is actually doing the job of the 90 degrees of those, right? The angle that is the binormal itself. I mean, the binormal is actually the average. So you want the other one that will cause us to see the other vector, I mean, of the curve itself. So, okay, we have the tangent, but over here, the tangent seems a little awkward, as you guys can see. So we may have to go back and check on what we did here. I think we have to make sure that no, this is not it. What is going on? I don't know why it's actually not going the right path right here. So let me check and see. Yeah, so it is doing, but I think the resample is causing problems. So I have to find out why is the resample making this issue. So it's pretty much like what it's doing here is I have to put the frame after because it's like averaging everything and it's not bringing what we want. So that's pretty much the reason. And it will be a good idea for us to actually do a blur right here. Just make sure it's 2 edges. Boom. So you can see now that because you have more resolution, it's gonna cause it to actually work better. So the tangent is actually working now. And I'm gonna put a little bit of blur because I think it's and then I do not want to pinpoint okay, perfect. So it kind of brings a little bit of smoothing. We may need that for some specific objects. So now that I did that, let's just test it and see if it actually works. It is working, but since we don't have, he doesn't know. I think there's a specific name for tangent, and I don't remember which one that I have to put. If it's actually up or let me see. See if I call this up. Let's see what it does. Okay, yeah. So unfortunately, Houdini will look for specific names that you may want to use in order for like copy to work. I do not remember how to make that a different name. If we look on the documentation, there's probably a place where it will say like there's probably down. For example, if I name this down, they can see that it will not work because it's not finding what is causing the whole thing, right? So I'm gonna put take off a marker and put it just take off the tangent and put a marker. And I think there is, so if I put frame here, let me see. No, not here. Another frame. Oh my god, I'm getting blind. Alright, so you can see that it has tangent U and tangent V, right? And I think that those are the names for it. I don't know. We have to find out. Let's go to documentation, for example, and just check and see if it says something about it. And honestly, fantastic job on documentation from Side Effects. It's like one of the best documentations I've ever seen about like trying to find things, and it really gives you fantastic information. So we can see here if there's something that tells us if there's any sort of like global variable in Houdini. Let's see. Okay, let me see. Tangent. Tangent normal, let's see. Or compute tangents, perhaps. It's loading. I don't know why it's taking so long. All right, so it's a VOP node. So there you go. There's this guys U10 and V10. I do not know if they will work, so we can test it. So let's go back to our guy right here and do U10. Nope, it doesn't. So let's just try the tangent U again. So I'm not gonna go further too much because I don't remember the name of the thing. So I'm gonna leave it up for now. Doesn't matter. So you can see now that the objects are falling, right? As soon as I move the curve right here, I'm gonna be able to have, you know, whatever we were looking before. And it's gonna keep adding some objects here, I mean, in the middle because of the resample. Since we did this resample like this, we want to make sure that it doesn't resample by a polygon edge because we want to have more cubes surrounding the areas. So you can see now that because of the curve, it's gonna keep adding the little cubes here and there. Okay, now you mentioned about yeah. So let me see. I remember trying to look at the Quaternion, but then Quaternion. Yeah, if you never play around with Quaternions, don't. Like for now, try to do the basic stuff. It is very, very. It's not. I mean, it's not complicated whenever you people understand, but it's not something that like you want to play around before you know more basic stuff. If you do, cheers to you. I took a long time to actually understand what Quaternion was and what it does. That's why I prefer Euler, but again, it's not as performant sometimes, or even like you're not able to do some specific things. All right, so what we can do here, okay, the easiest way that I would do it, as you mentioned before, there is a thing here called, I'm going to put as normal. There's this Archimedean spiral, and you can see the how actually I ended up actually learning this way. It's incredible how that worked. So you can see the function and how actually it was done. And I read it, like I tried to make sure that, oh, okay, I understand what's going on here now, blah, blah, blah. And I found a way that you can actually do some sort of interesting aspects of the normal. So if I do here and show my normals, you can see that because of the amount of turns that I'm doing, I can do the radius. And the normal is going to change behavior, as you can see. And if I put this before, of course, the whole thing, it starts to rotate, and you can see the amount of turns that it's doing through the whole thing. The thing is, this guy is using the relative bounding box, okay? And we do not want that. We want to use the resample. There's a curve view right here, I believe, or there's actually a there's another attribute that you can do, maybe arc length. I don't remember now, but let me try. Let me see if this works. So let's go there and try to change this function. So it's getting the radius and the relative bounding box. So right here, we may be able to just do this and put a curve view. I will try. I'm not sure if it's gonna work. Okay. And all of those that have this, I'm gonna do like a search and find, search and replace. Okay. Replace with. Yeah, find next and replace. Oh, sorry, replace all. Let's see if this works. Yeah, so it's giving me problems because I believe. Okay, has curve y. Yeah, so it's getting the function of y into all of those. I don't know if that's going to give me issues. So let me try to do this and see if this works. Because I may be doing a hack over here, and I don't think this is gonna work the right way. But let's see. Apparently did. I think it did. Perfect. Okay. So now it's actually doing through the curve U, right? It's rotating the amount of turns into the direction that is going there. So you can see now that I have plenty of rotations, and I'm able to just rotate the vectors that form. So if I end up creating way more points here, let's just do 0.25. You can see that it's going to rotate this way. right? And I'm able to copy those objects, and it's going to do like a sort of swirl, right? So that's pretty much how I would approach this. There's other ways where you're able to, I think there's if you end up creating a curve that is the same behavior, I mean the same amount of points, or even you can trace it, where are the normals, and then as soon as you turn the curve or the other side or whatsoever, it's going to bring you where you want the normal to be. But that's going to take a longer time. Perhaps we can do another day, because we need to start getting back to the other subject. Does that help you, Evany? I hope so. Yeah, there's the Archimedean rotation, and there's another one here. Let me show you. Go through that list right here. It will teach you a lot on how to actually approach these things. Okay, so there's another one right here, which is, I don't know what this one does, but let's see. Yeah, so this one does a little bit different. I think it changes with cosine, or there. Oh yeah, you can do by the ramp, so you can select by the ramp where the angle wants to be or not. So something to play around with. Hope that helps, man. All right, let's go back to our prop. So I'm gonna just hide this. Alright, so now we have this. Yeah, the normals are crazy big. Yeah, I appreciate the question, man. I think you're the first one that actually requested something. So anytime, please, guys, request, and I'll do my best to explain what I know. If I don't know, I apologize, but I'm sure we can find some ways. Alright, so let's get back to it. Alright, so now we have the block out, and we have a bunch of graph right here. So we want to make sure that we clean all this stuff up before we actually move forward. I ended up doing a little bit more work on this, and honestly, it's not a lot. What happened here, it was that let me show you. We were here, I believe, and we did this, yeah. Alright, so what I did here was I pretty much got this cone right here on the top, and I ended up doing a bevel to the point that is on the top. Okay, so what I did here was I select the point, right, and it just makes me divisions and make sure that it's the solid one, and you can do by just bringing some divisions there. That's what I did, and then by hand I just ended up bringing a lot of divisions to the mesh. You don't have to do it that way. There's probably easier ways. And then you extrude. I extruded the mesh. I beveled just the edges there right here, so we have a little more reinforcement. And we will go there and get this guy. Okay, so that's the only thing I did by myself. I just wanted to show you guys what was it. Let's get back to our image and see what we have here. I want to make sure we know if it's correct. All right, so we know that there's another little lip over here on the bottom, and we may want to do this. Maybe it's actually just stains. I'm gonna leave it blank for now. And there's a little swirl object going around the edges there. So let's play around with that swirl for now. So let's do that. See that now that we have that arcade, see that was actually good, because we're gonna need that now. We're gonna need to turn some swirl objects, but I actually want to do it in a different way. I think it's good to play around with the different methods so we learn different things here. So I'm gonna try to minimize all of this first. So I'm gonna bring this to another subnetwork, and this guy's over here too. Yeah, over here is fine. Perfect. And if you press L on your keyboard, it's gonna automatically do this. I would avoid it as much as possible because you don't want to get lost, and I want to make sure you guys kind of follow the graph where I'm going through, and because sometimes we're doing so many changes on the graph, and people will get lost if they don't see exactly where I'm positioning options. I mean the nodes. Shift L would actually only lay out the selected nodes, by the way. There you go. All right, and if you press Shift S on your keyboard, there's this method of actually working with the lines. I don't necessarily like it much, but people can use it. I'm gonna close this, guys, because honestly it gives us more room, and I can just use the P on the keyboard. Grab my God. Yeah, I can understand. So if you press P on your keyboard, you're gonna see the parameters over there on the side. And now that we have this, let's get some of that swirl. All right, so we want to make sure that we don't have. Let me see where it is. See, even I did get lost right here. So it's over here. Where's the cone? Right. So I want to make sure that we don't have much of this lip. I'm gonna. Sorry, my phone. I don't want to have that much of that lip, so I'm gonna try to not put as much there. So I'm gonna just tiny little bit. Let's see, how do I do this? Oh, we can just do by hand. We can do select the edges. I'm gonna scale it down a little bit. There you go. And go back there. Okay. And now we know that we have these edges right here. So I think there's a thing called edge to curve. Let me see. Yeah, so we can do labs. If you have the labs tools, you're able to bring the edges selection that you have as the group, and it's going to transform that into a curve. So I'm going to use that. If you don't know what labs is pretty much game development tools for Houdini. Fantastic job from the guys at Side Effects. They pretty much created a team that brings you so many things game related, but also not just game. Basically, it has a lot of other different things that are extremely useful, and it optimizes a ton of your time. Sometimes you don't want to have to deal with your own time to create the tools, and there's plenty over there that really will help you optimize it. So now that you can see that, I'm able to select the edge loop, right, pressing twice, and it just brings me this curve. So I'm gonna bring that here. Yeah. Indeed, rest in peace, Maya. Yes, I said that 4 years ago. I still use it though. I completely understand your heart though. It's certainly something that I stopped. I just can't. I mean, so I have to use it, but I don't like it anymore. It's not for me to. My head doesn't fit with whatever Maya or Max or other applications that only do direct modeling, and I have to rely on procedural. You just can't anymore. It's impossible. So, all right. So let's do this. I'm gonna put a resample here because we want to have more points surrounding this. And instead of that, we're gonna put this to by polygon edges. And I think that I need something a little bit different here. So because of the fact that this, I think it's connecting the endpoints, but I think it's not closing it. So we may have to find out if actually it's creating more points and is not sorting correctly. So there's a thing called, I think, polypath, I believe. Let's see if this solves. Okay, connect endpoints, okay. And then we're gonna sort it. I mean, you don't have to sort it, but I would prefer to. And the point sort order you can do along vector, or actually not along vector, sorry, spatial locality. It will give you a little bit better numbers, but it's not correct, as you can see. And I think there's I can't remember, by vertex order. Yeah, there you go. So basically the vertex order is going to recreate the points in the curve with the correct numbers. And now we can probably use the resample. Let's see if this works now. Yeah, perfect. Okay, so now we have more points in the surface, and we're able to start playing with the how the swirl will work. One of the things is, as you can see, we have this little indent right here. We may not want this, so let's do, I'm going to do refine. And in this refine, I'm going to unrefine. This way, we are able to not have those points and still resample without those points. So it's something to avoid any issues later on. I'm going to save the file and make sure that this is a template. So we are able to see what's going on with this. And let's see if it's correct. So what's happening here is, because I put a polypath and the refine is too strong, we want to make sure that it's less, because we want just those points right here. So that, unfortunately, there is one of the things about this tolerance U, I don't necessarily know if it's angle based or it doesn't give you. I mean, we can try to read it here, but yeah, tolerance U. But I don't know what that tolerance is. It's something that I can't explain what is the number references to here. So if we go to documentation, might say. See. Actually, you guys can check it out later yourselves. But honestly, I've tried to find a way where, by default, it will give you an angle, but I couldn't. Perhaps if anyone knows, I would love to know. All right, so let's do this. I put the points there, and now remember we had that function there. So I'm actually gonna copy that. No, actually gonna do it a different way. Let's do this. So I'm thinking about how can I do this. One second, guys. All right, so we can do perhaps a sweep. Okay, and in this sweep, I'm going to do a circle right here. And in this circle, make sure that the scale is much smaller. We put it like 0.01 for now. And I want to make sure it's polygon based. And I'll just do 8 sides for now. Should be enough. Actually, much smaller. So let's do a 0.001. No, 2.5. There you go. And then what we do here is I want this resample to be in this cross section, and the backbones. No, it's actually opposite. I apologize. Let's do this. Now you can see that it's actually causing the whole part. It's creating a loft, I guess. I don't know. Maya is a different name. Max is a different name, but pretty much it's like an extrude by this shape right here. So, and the sweep itself, if we look at it, you can see that we have something called roll and full twists. Okay, so we're gonna use that, but we need way more points in order to do that. So I'm gonna do this right here, and then I'm gonna put this as, let me see. Okay, that seems a little bit better, but still not something correct yet, because one of the things that we may want to do, and I'm gonna take off the template right here because I want to see the points better. And you put this to be even less. We put it like 2.5, because we want a noise right over here, like up and down kind of thing, through the normal of this curve, and that is easy to do. It's easy, but it's I mean, not easy, but I think I have the solution for this. I'm gonna put a polyframe on this guy. I'm gonna bring the polyframe there, and let's do up and bring the normals to be this way. I'm gonna press D on our keyboard and just try to not have the scale of normals too much. I already decreased the size. Oh yeah, so okay, the thing is the up itself we don't need to see right now, so we're gonna avoid it. And then now what we can do here is I'm gonna add a VOP node, point VOP node. Bring that there. And I want to have a cross product right here. Make sure I have the cross product first. I'm going to bring this to the normal. It's good. Perfect. But now what we need to do is I want to put like kind of like a little swirl kind of thing over here. So what we want to do is we want to create, let me see, a ramp perhaps. Yeah, we're gonna create a ramp, and I'm gonna put mirror ramp on this. So as you can see, what it's doing is it's getting me a U coordinate, okay? And this U coordinate, let's just say I put anything over here. So I'm gonna put a vector to float, and I'm gonna use the Y. It might be the Z that I need, but we'll see. I'm gonna put a scalar. Let's just take off the normals and see what it does. Yeah, it may have to be the Z. 1 second. All right, so what it's doing here is causing this ramp, and you can see that the frequency, the more I add, so if I do this perhaps, I don't know, it might actually be the X. So I'm trying to find which one needs to be. It was supposed to be that. It is doing, but it's not correct. So I'm trying to find why. Mirror frequency. Oh yeah, because I need from the cross product. My apologies. Yeah, there you go. And then now let's do frequency 1. Frequency 5. I don't know if it's the X or ZF. I always forget. It's supposed to be doing, but it's not. What am I doing wrong? Give me 1 second. I need to think about this. Trying to understand. Okay, so the U is supposed to be let me put this as the color over here just so we can see what is the cross product doing. Okay, okay, since it's not that, I don't know. We don't need the normals. We need the curve view of the resample, which is this guy. So we're going to use that in order to, so I'm going to put over here bind. And in this bind, I'm going to bring this information here. I'm going to bring that there and see if that works. There you go. Perfect. So now we have, so basically the curve view, it will give you it's not the distance, I believe. I think it's the, how, like the direction of whatever the curve is doing. Let me see here actually what it says. Yes, so it's the U coordinate of whatever the curve is doing. So if you actually do a UV for the curve, you can even see this way. Like, it's interesting to actually understand, because a lot of really cool things that you can do on Houdini is you can do by UV first, right? So if I put this guy here and do a arc length spline, you're gonna see that all the points are right there at the bottom. So let's just say I do some things that I transform on the UV world. I can bring it back to the 3D world as well. So there's plenty of ways to do that. You can look online. There's plenty of tutorials for doing that. It's really interesting because it actually saves you enough time, a lot of time. So now let's go back there and do mirror ramp, because we want this to be that way. And let's do perhaps 32, no, a little more. Do 128, and there you go. So now that we have this, we want to make sure that we move the Y, okay, section of this gentleman right here, or we can do a displace by normal. It's up to you guys. I can show both ways. So I'm going to use the Y right here, right, and I'm going to add, but I need another vector to normal. Well, the computer's getting slow. I don't know why. Vector to normal. I mean, sorry, float to vector. And we want this guy right here to bring it to be the Y, okay? And you're gonna bring those guys together right here, okay? And we want to add the position of the world together with the difference that you have here. So if we bring that to the P, you're gonna see something crazy like that, which is fine. We're able to handle this really soon. So what we can do here, let me just test it without it first, so we are able to see if it's exactly correct. Okay, yeah, it's adding a lot, and it's the P only. So what we want to do here, I know what's going on. So we don't want to add like right here. We want to make sure that this is here and that guy there and this gentleman right here and this guy right here. Perfect. Because we don't want to add to every single coordinate. We want to add just to the Y section. Since it's doing a lot over here because of the ramps, the ramp itself, if you actually even see like the blur over here, if we add less points, it's gonna do that for us. But we want to make sure that we have less intensity because you're literally adding the world itself up, which it can cause issues. So we want to do a fit range right here. And I'm gonna make sure that this fit range, whenever I add this guy, it will not add as much. So I want to bring this value of over here down. So I want to make sure that the maximum value is like 0.01. So you can see that the ramps is really doing this job. I'm gonna do a little bit less. Perhaps like this. Let's just check the concept because I want to make sure that I'm doing the correct thing. Yeah, well, yes, in a way I am, but there's some other things that I still need to think about how to approach the Otter. So that whenever you do a swirl, we may have to do some different things here and there. But let me do a little bit less because it seems that it's not too as many points. And since we have 64 points of frequency right there, what I want to make sure that I have is the resample. Should be a number that is divided by 2. So let me think. Let's get a calculator. That's the one I have to think. Alright, so we want 1 divided by, I use 64, so let's do 0.05. Let's copy this value. It didn't. Or you can actually just type it 1 divided by 64, by the way, it will work, okay? But because it's actually, the frequency is larger, so we have to make sure that it's less. So let's do 128, okay, there you go. So it makes it as the same way as power by 2 with whatever the frequency was doing. And now what you can do here is, let's just say I had this number, let me do something really cool. I'm gonna add a parameter here. I love doing that stuff because it just makes more organized, and also we can change things later in our while we're doing things right here. So I'm gonna put over here the frequency is 128, right? And I'm gonna copy this parameter and I'm gonna paste this parameter right here as a relative reference. So it means that I am sending this value right here, and I'm able to copy this parameter as well and bring it back right here to the point VOP and bring it right here and divide it by 2. So that means that if I change, where is it? Resample. If I change this, it will also change the ramp inside of the VOP. So just something to be aware of. I'm gonna put this as 120. No. Okay, so now we have this. I want to make sure that I have another ramp inside of it, but with an offset. So what we can do here is I'm gonna alt click and hold this guy, and I'm gonna do a little offset, which this offset we don't know how much we want as, so we have to find out a value of what the offset is gonna do. So let's see, I'm thinking, I think it's 0.5 should be enough, because actually it's gonna bring the value of whatever it is on the other one. And we pretty much want to add again, so I'm gonna put the fit over here. Okay, since we have the speed, I'm just gonna organize this guy a little bit better so we can read. Oh, damn it. All right. Since we added the add over here, actually I prefer this in UI over here, like the lines, Shift S on your keyboard for inside the VOPs. But outside, I don't know. It just makes me feel a little more lost. All right. So this fit, it can be the same value. it's not a problem. But we want to make sure that we add on wherever the normal of the curve was doing, right? So what we want to do here is, since we're adding this position, right, we know that the cross product is here, right? So I want to add another vector to float, and I think that's supposed to work. And I want to make sure that this is displacement by normal. Actually, yeah, no, we don't need a vector float, my bad. We're just gonna need the position right here. I want the vector, the normal, right, which I created by the cross product. And I'm gonna bring the fit over here to the scale. And as soon as I do this, I want to combine those two guys together. So what we can do here, we can do, let me think. Yeah, we can bring this guy here, I believe. I hope so. Yep, and then add the displacement right there. So it kind of brings that sort of swirl look like, kind of feel. Just something to that will give us the functionality for the sweep, right? Which is what we wanted right here. So I'm gonna delete the color because we're not gonna do this anymore. So I'm just gonna take it off. See, it seems complicated. Yes, I know it's we're using a lot of our time for this, but you can save this tool, for example, right? And you can reuse it in so many times in your life. And again, I understand the fact like, oh, we're putting a lot of effort for just one little tiny detail. Yes, you are. And a lot of people talk to me about it like, well, damn it, man, I will just take like 5 minutes to do in other applications. Yeah, okay, then again, use that application and go. But I can't stand the fact that I'm unable to customize my own things, right? So that's one of the the things that I think about. And now you don't necessarily need to have this swirl, I believe, the full twist. Let's see. Wait, we need way more points. So let's just do 256. Okay. And then, yeah, we may need a little bit of twist. Let's do one. Actually, what we can do here as well, since we had this number, I'm going to copy this guy and perhaps divide this by 4 or something like that. So I'm going to put references and then divide by 4 or even more. Let's do 32. There you go. So it's kind of like, that's how I would have tried to approach. You can do divided by, like it should be less, but yeah, 16 is good. So that's how I would have approached doing the swirl, per se. And if you wanted to do something a little bit like that, actually cross-section in between two, all right, you can. What you would do is you duplicate this guy, for example, and you just come to the ramps, and you just do an offset that is like 0.75 here and 0.25 there. I think that should work. And then you merge the sweeps together. And let's go back there. I think it needs to be more offset. Perhaps this needs to be 0.5 and this needs to be 1. Yeah, maybe 1.5 here, and the other one is 1. There you go. Pretty much that's what I would do. Okay. And then we can go, and now that we know that the values are there, we can manage the frequency however we want here. So I'm going to put a 196. Let's see if this is better. There you go. Okay. So now let's go back to our whole section where we had our guy right here. Right. We know that we have the swirl. Let's just check the reference and see if this is good. Yeah, it's not amazing, but it's fine. What we can do here is actually it's only one curve on the reference. I just didn't see it. I'll just do it in one curve because I think it will look better at the end. So I'm gonna just save this and leave it on the side. But what is happening with that guy is that curve, I mean the whole silhouette of the whole thing is actually, I believe it's probably 6-sided, and it has a little kind of like indent on it, and it just twists, right? So I'm gonna do that. We didn't even need to do all that stuff. I just didn't see correctly what was on the reference, but again, we learned something. We're gonna put 6 over here, okay? And I want to make sure that I do a bevel. And on the bevel, I want all the points. So I'm just going to put this as all the points. If you do an asterisk on the group, it should select everything. And let's just put a bevel on all the points. Very low, small amount. There you go. But we need 2 points. And we want to make sure that is, let's see, round. Round and round. Actually, I'm going to do solid. I think it's better. And now we want to select the points by hand. I'm not going to do procedural over here. We could, but we don't need it. So I'm going to select by hand the points that I want. I want to make sure that this wire is super thick right now. Okay, so select all the points that I that I don't want. Oh, what's going on? I'm gonna invert the selection right here. 1 second. And invert selection. Since I have this, I will make sure that I scale those guys down a little notch. Not as much, but like this should be good. And we can add another bevel, but let's just see how this goes. Let's see if we put on the thing right there and see if this works better. So we didn't even need the swirl. Like, it's just the fact that we just had this, it should be good. Because honestly, it just swirls in itself. It doesn't swirl outside of it, which is sad story. We already did it. And now I'm gonna scale this guy a little bit up. And I think it's less turns. It's turning too much right now. It's not doing. Let's do divided by 32. Too much. Let's do 24. I think this is enough. Perfect. Okay. Now that we have this, let's try to combine. Oh yeah, Jedi level VOP action. Oh man, I seen people doing miracles like in VOP, like it's crazy. But again, I would advise to doing Vex itself, like code, because you can do so much more in Vex faster in a way. Because if you know Vex, you know exactly what VOP is doing. If you actually see how it compiles, you can see how the thing is compiled in the way that the VOP is working. You're able to see how it gets compiled, and you can see the code of it. I don't remember where was it. I forgot. There was a way that you can. Oh yeah, there you go. View Vex code. So you can actually learn a lot of stuff here too. Again, a lot of things is library and like bunch of references, but the functions are there. You can find it a way to actually understand and bring it to a Wrangle node. So I learned a lot of things that way because I wanted to see how what am I doing in VOP is gonna bring it to the code. But again, it's you can see the amount of code that is there. Just by changing just one normal, it will still have all that library. That's one of the reasons why the point VOP is a little more expensive than Vex, right? Vex is much faster. So, anyhow. Alright, so let's go back to whatever we had here. Let's do a merge. Let's, I'm going to do a subnetwork here. Okay. So we know we have the sweep, we have those two objects. I'm going to merge these guys. There you go. Bam. And bring it back to the bottom right there. Yay. I'm going to do a normal here. Make sure we have I usually like to see all my stuff with normals because the way the I hate like seeing like just faceted normals. I don't know, it just drives me nuts. It's kind of like it's broken, you know. I need to see correctly. So I like to use face area because it gives that kind of notion of how the faces are, you know, being pointed out and in. So okay, we're getting there. It's almost uh, perhaps like 80% of the way. So I'm gonna take a break real quick, guys, like maybe 5 minutes or so, and then we're gonna start this guy and finish the cross and get to the VDB side of things. So we're gonna start adding sort of little voxel based, and we're gonna bend things together and be able to create a really cool high poly, and go from there. So 5 minutes, I'll be right back. All right, I'm back. Apologies. Let's go back there. So, okay, let's see if you. Let me know if you guys are able to see the screen. All right, so what we can do now is we're gonna go back to our reference, and over here, everything we can deal with just curves, right? There's some little shapes in there that may require a little bit more work here and there, but one of the things that I noticed is on this swirl over here, right, on this kind of bracket, I don't even know what that's called. We can go to our Houdini back here, and we're gonna be able to add, put this out and kind of like add like a little curve. So what we want to do, we're gonna go back to our curve right here. Let's see where it is. Right here. And we're gonna add some points here and there. So I'm gonna make sure that I have this as reference. So we're gonna put that as reference and bring the curve right here and find ourselves the points. So you can see that we're able to see the points there. The thing is, we have a refine right here, as you can see. And how we, okay, so there's two ways we can do this. So let's try to do by just the curve itself and see if it works. So I'm gonna add a point. If I add a point right here, it's not gonna do much because we need 2 points. So, and I want to manage this point to go out. So I'm gonna move 1 point up right here. So I'm gonna try to do that the best way possible. And add this point to be right here. And bring this in. And on the bottom, I want this point to be a little bit more out. So you can see later how that's gonna work. But we need as well like some sort of support points over here and there. So I'm gonna add 2 over here. So it kind of brings you that indent per se. Okay, let's just see if this works and we can move forward. A little bit less. Let's just go back to our curve. And we can add more points to the resample in order to avoid this problem. Yeah, it seems that I'm gonna have to. So let's go to resample and do like 0.005. Okay, so this way we have a little more control over what's happening. And that seems to be a little better. All right, because it's outside, right? The reference is actually showing that this is outside. Also, another thing that I noticed is that it's a little thin on how it is by the thickness of the front of it, but by the sides, it can be a little bit more spread. So let's just bring that as well over here. So let's just bring that value a little bit larger. That's the beauty of procedural. We can just come back and forward. Again, you can break this graph, right? And have this guy now working correctly, because honestly, actually, it is breaking already. Because whenever I do this, the crease over here, it's still adding the faces the way I want it here, but at the same time, it's getting me some more other weird issues. So I'm gonna try as much as possible to add more points. I'm gonna put like 0.2. Let's see if this works, and then the refine itself. Let's see. Let me put that back. What is the value? It's pretty small, but let's try a little bit less. Because I want to have a little bit more resolution. Oops. Yeah, it's annoying because my Houdini scene is so small, like in decimals, that this is gonna cause me to have to do something here that will actually help us out. I'm gonna scale that back up. So I'm gonna bring that to here, scale that to perhaps like 1,000. Refine, let's see. and that seems to be a little bit better. And then now I'm able to just use a number that I feel more comfortable with. There you go. Yeah, that's a little bit better, but still not. I want like some more support points right here. Good, perfect. And now I'm able to scale that down again. I mean, that is a hack, okay? I would just literally try to do the right scale. The fact is that we're using units as the way that the human guy was before, and that's what I was following. But I would scale that guy perhaps to 1,000 and then start from there, because the way that the scale is in Houdini is different in other softwares. I think at one unit in Unity it's 100 in Houdini. I don't remember now. So now the way I want to do this is I want to just make sure that I put 0.1, which is the scale that we were looking for before, and let's do that here. And there you go. So basically I just use the scale to come and back forward so I can have a little bit more resolution on points. And now it's a little smoother, right? And the bevel will follow whatever we're doing before. Perfect. Now let's go back to our section that is the in the reference, which we want to make sure that we have those lines. So you can see that I already did the high poly for this guy, but the other stuff doesn't have it yet. But we'll add it later. We know that we have this, right? And we know that we need a reference to understand where is this space in between whatever we're going to do for the middle section. So we know that the coordinate that we are using is here, and Z is a little bit easier to see the face, right? That we have right there. So I'm gonna go to our front viewport, okay? And I'm gonna use this guy as the sort of like a reference to cause us to bring a curve and able to kind of select the primitive itself and able to snap into whatever is doing. So how do I do this? There's two different ways. I can come here into this guy, select the face itself, and there is supposed to be something that makes us able to, let me see. Believes that that's what it is. Let's see. No. If I remember, there's a way of you actually construct plane handle, and you're able to select where that goes, but I don't remember where was it. It's going to the viewport itself. So I'm trying to find. Yeah, I forgot necessarily what was the case, but let's not use that then. I'm just gonna revert to the defaults, and I'm just gonna use this face as the reference, but I don't know if it's gonna snap correctly. So the way I would do this is press X and hold in your keyboard, and you can see that we have primitive. Okay, as soon as I press Enter on the viewport, and you can see that is actually giving me right what we wanted to snap on the primitive itself. So I'm gonna go back to our reference and check. So, okay, so they have an arch, right? And so it's a cross over here and a 45 degrees cross in the middle. Perfect. So let's just do that. And again, it's procedural, so we're gonna be able to come back and forth anytime. You can see now, I'm adding the point right where the primitive is, right? I'm just gonna add like simple points in order for us to at least get the reference correctly. I'm just pressing Alt Tab all the time to see if I'm doing the things correctly. Okay, perfect. That seems to be good. I'm gonna press Enter, and then I'm gonna press Enter again, and I'm gonna add some points in order to actually create that curve along the side. And I'm gonna move this point to be around here perhaps. And I'm gonna add another support point to be right here. And bam. Okay, that seems to be good. Okay, so then now we want to create a sweep as well. So, or you can, if you wanted to like optimize your time and just forgive me, add poly wire, you can. So I'm gonna show the poly wire because it's honestly I'll show both ways if you guys want to, but poly wire is so easy sometimes to just play around with, and it just gives you what we want. And there you go. See, like, it just makes the work for me. And since I have this, I want to make sure that this guy right here actually crosses over to the other side. Okay, because I want to use sort of like a clip and mirror that guy. And let's see if there's any points. Okay, there's none. Perfect. So now I'm going to add another curve right here. I'm going to put right in the middle, so I'm going to bring the interface to Y to be like this, and just to see where I'm bringing the point to be. I don't know if this is the front or, let me see. I believe this is what I need to do, yeah. Alright, so let's just add the point right there, and another one there. It's not working, 1 second. Oh yeah, so I need to select the object right here first, and then bring it there. Okay. Perfect. I'm gonna merge those guys together. So I'm gonna bring another poly wire here. I think you're able to actually bring the poly wire after the fact, but I prefer just avoiding that issue. And you can see that the coordinates of whatever it was crossing there, right here on the X, whatever you're doing on the X, you're just able to press 0 on each one of those numbers, because then it's gonna center out the 2 points right where the X is. And we need another one, which is, yeah, I'm gonna just do this and that as well. And I'm gonna be able to just edit this guy. And so, since I need this as reference, I'm gonna bring that guy there. And let's check on perspective mode. Yeah, so it didn't do correctly because he was not using the primitive right here, so we need to use the primitive snapping. Let's just check the reference. Seems to be fine now. And the Y section of this needs to be exactly the same as well, so we're gonna make sure we do that. So on the Y side of things, we choose one of the points right here, so I'm gonna do like 0.4 perhaps. And select the number right here and put the same number on the other guy. So we know that, you know, it crosses and it's all good. I'm going to use the world coordinates. Actually, it's already world, so I'm going to bring that point a little bit less than there. And I'm going to take off the snapping. So it just gets right to where it's supposed to be. So if I did this, right, and I have these points crossing over each other, you could do something really interesting, and I'm going to show you guys. Instead of actually using the poly wires right here, I'm going to take this off for now. I'm going to take this off, and so I know I have this curve. I'm going to put the template. This guy can have a point which is exactly where it is in the middle, so I'm going to add a point right there. I'm going to move it in order to bring exactly where the other point right here is by this. Okay, so we know that the point is there. And I'm going to add another point in this, or I should just move this a little bit down. And then this gentleman will have those points being exactly where the other ones are. Yeah, perfect. And this as well. So I'm gonna bring this point right here to be right there. Alright, cool. Now that we have this, actually I'm gonna add another one just as support over here. Perfect. We have those 2 points on the bottom, and we may not need it to conform with them, because actually I think they're going inside of the surface. So let's just check to make sure. I have to add a point right here. 1 second. A polywire. Let me see the reference. Yeah, it seems to be okay, but again, we're gonna be able to fix it by different ways. You can just go here on this point and just pretty much bring. It's funny because like, as points, it doesn't actually follow the coordinate or whatever the axis is going, but if you actually do a netted mode, so for example, if I do a netted node right here and bring it there, and if I want to edit this, select a point. If I press T on my keyboard, if I press M, it will toggle in between different ways of getting the whatever's going on with the line. Since I don't have a normal, it's not going to be able to find out. So how do I fix this? Or you add a normal for this, or you just put a little bit on the bottom right there, and then just fix the point right here where it's supposed to be in the center. So just go there, like boom. I'm just gonna put that point there. I'm trying to find where the curve. Okay, there you go. Yeah, there you go. So now that we have those points all together, I'm going to take that off. I want to fuse this. I'm going to add another curve just to make sure that I have... No, actually this is fine. I'm going to fuse those points. Save the file. Sometimes it gives me issues. Whenever I fuse this, you will see that if I bring this to be the merge, you have two numbers. They're supposed to be on top of each other, but it's hard to see. Okay, so as soon as I fuse it, you will only have 1 point on those guys. So that's something that, let me see if I'm able to increase the guide font large, yeah, a little bit better, just so you guys can read a little bit better. And so we do, see, like it kind of crosses each other like there. It's just having 2 points. So this way I am able to have the polywire, and it actually does a good job on holding those faces right there. And if I do this and do segments, it would kind of increase the resolution there. And I want this to be no smoothing point, or I do. So it's up to you, whatever you want to do. Okay. I just want to show that solution that I find it like easier to play around with, and it works. You know, it just gives you what you really wanted to do before. Since I don't need this edit mode anymore, I'm just gonna put that down, and I'm gonna bring our point again over here and bring it down a little bit. Alright, so let's check the reference again. How do we have it? Okay. That's it. Seems fine. I mean, I'm overcomplicating this. Sorry, I'm just trying to get this as quick as possible for you guys. So we have, I think it's four-sided, right? And since it's four-sided, we are able to turn this in a way that actually managed to be square by an angle. Okay, so we're able to say like, oh, where is the joint up vector, right? So if you try to find out by hand right here, you're gonna be able to see that it actually is turning the polygon right here into square, not necessarily what it was before. So you have to find where exactly it is in order to do it. But I would you know, like by hand do this, but you are able to see how much is the angle of what you have and whatever is causing the up for this to be, and then that will cause you to get you what you need. But again, why bother if we're able to just see what we're doing right here, right? And now, before I actually do the job of the fuse, I'm able to bring that guy down a little bit here. I'm gonna put a resample before everything. Resample and then do subdivision. Let me see. Yeah, resample by polygon edge. Let me see. Okay, we're starting to get points there. There you go. So it's very small amount of points, but it's doing its work. The thing is, it's adding some points here and there. I don't know if it's going to cause issues whenever we fuse that, but let's check and see. I think it's okay. Yeah, no, it's not fusing, so what we can do here is, let me see. Let's put straight edges. Let's see what it does. Okay, no. So it's actually it's pretty much getting the part where the fuse is and doing a bad job. So we're gonna bring the resample after the fuse, and I'm gonna do a fuse again because we need to fuse the points, because resample by itself it kind of takes off the fusing. And why is this not working now? Let me see. Yeah, so it's getting annoying because it's getting to it pretty much is not following the length of it per se. Trying to get this correct, guys. 1 second. Let's do it this way. Let's think about how can we approach this better. Well, the support amount is good, so I'm gonna need, well, we can do this. Okay, so let's do a resample over these guys right here on each one of those, and make sure that it resample by polygon edge. So I'm gonna add a number that is small enough. Now we can see that this point is gonna stay on each one of them, and that's what we need. The thing is, you can see, like, as soon as I put output to polygon curves to subdivide later, it causes that. I don't understand why, but that's what it does. So I'm gonna leave as straight edges and not do the subdivision. I'm gonna leave it that way. And this guy, we will need subdivision, but again, we don't have a choice. We're gonna have to snap it later. So let's just add the subdivision and we add it later. There's nothing we can do. Maybe there's another solution, I just don't know. And you can see now that, like, this is wrong. Right. Then we can go here on this merge, right? And we're gonna edit those points. It's just, I'm more overcomplicating this. Oh my god. Let's just do that. Perfect. Okay, that one is gonna fuse no matter what. And now we fuse this and polywire. Bam. Okay, perfect. Now we made it work. But again, the smooth point is causing some issues there, and I don't know why is that bringing some sort of weird. I'm not gonna use the up factor. You know, I'm just gonna leave it this way. I think it's enough. Or I'm gonna be spending so much time trying to get this correct. Okay, that's good. I'm not gonna bother with this. But if you wanted to see it in a different way, you were able to just get the sweep, right? And let's create a grid right here, for example. And in this grid, I'm going to bring row 2. And the size of this grid, perhaps 0.1, 0.1. Save the file. I'm gonna put a sweep. sweep, baby. All right. And this is the backbone curve, so I'm gonna put this guy here. And the direction of the plane has to be different in order to work. Okay, so this is the direction that I want. And I'm gonna scale this to be less. So I'm gonna do 1025 perhaps. And I'm gonna do three sweeps over here. So I'm gonna bring that guy here. I want the backbone there. No, the other one. Oops. I don't know. Yeah. And then another one here. And we should be good. So you can see that actually gives you the option of having the shape itself. But the problem is, as soon as we merge those guys, you can see that this is going to be a little bit of a problem. So this is why the reason I was doing with the polywire. And it's already gets like merged, but it's okay to use it that way because we can just simply mirror after the fact. So as soon as I have this point right there, I'm gonna do another thing here that makes it easier for us. So actually I don't want to edit the points anymore because I need to edit before the fact. So I'm gonna add it over here. I'm gonna cross this guy out, okay? And I'm gonna bring this point to be the end of this right here. Bam. Okay? This way we have exactly where it meets, right? And it closes whatever is there. And now we're able to mirror some of those guys. So we're gonna do, let's do this. Let's get the middle section, which is this gentleman. I'm gonna toss it to the side, right here. I'm gonna put this grid up, shift down, and I'm not gonna merge those guys together yet. I'm gonna bring those two right here, and then I'm gonna do. So in the labs, you have something called lab symmetrize. But I'm gonna show but with the symmetrize, but you're able to do that by hand as well. So you're able to just change the angle right here. I want the X, so I'm gonna put 0 right here, 1. Actually, it's minus. So it does the job for you. As you can see, it already merges and clips. But if you wanted to do by hand, you can. So just can go here, put a clip, and in this clip, bring it to 1. On the X, oh sorry, right here. 1 here, this guy, we don't need anything, and 0 right here. Actually has to be -1. Yeah, where is it? What's it doing? What are you doing, buddy? Oh yeah, no, origin has to be 0. Forgive me. So now it's clipping that whole section, and then you can use a mirror after the fact. And as you can see, it does the job. So it's the same thing. It's just that symmetrize has some different things here and there that they're adding. So I'm gonna delete the symmetrize. We don't need it. And now I'm going to add a reverse node. Let's just organize this because it's getting large. Let's bring that there. And I'm gonna do a poly fill. And the poly fill itself, it will automatically find faces that are open, okay, and I'm gonna close. And just make sure that, just so you don't have any issues, just put a simple polygons, okay, because it pretty much, you don't want to add more triangles if they're not necessary, right? All right, so now we have the sweep and all that stuff. You can see that some of those normals are not that well done over here, but it's okay because if you look at the reference, it's very human made, right? So we don't have to like rely on putting a lot of attention to some things that are so small. I'm gonna bring the scale up, and since we have this, we want another merge right here. I'm gonna bring these guys down. And I wanna have that in here. Bam, perfect. Now that we have this, we're gonna merge back down to what we had before. So what is this? Let's see. Yeah, it's the polywire stuff. So we don't need that anymore. And I'm gonna just do a subnetwork with this, just so the graph is smaller. And let's merge that right here. And bam. Okay, cool. Actually, I forgot to polyfill the other one right there. I don't know why it's not. Let's see why. It was supposed to. Oh, okay, why? I know why. Perfect. Oh yeah. Okay. Yeah, it's still open. Why? No. There you go. So yeah, one of the things is you don't want to keep merging the same object in every way. So okay, now we have the cross. We are able to go do a copy and transform. Let's just do 6 copies and do a 60 degree. And you can see that we have our little cross right there. Let's just see. It actually touches the top, as you guys can see. So perhaps one of the lines that we have, I'm gonna lock this now. This viewport, as you can see, I'm locking over here, and I'm able to go back inside of whatever we had without losing any other information. For example, if I unlock it, it's gonna just see whatever's inside the subnetwork. So I want to make sure that I lock it first and go inside. I'm able to edit whatever I want. Let's see if that's the point I want to edit. And the only problem is that you're not going to be able to see what's going on. So what we can do here is pretty much, let me see. Let's do a, I'll hack here. Do a transform, okay? And in this transform, the pivot of what we want right here, I want to be in the center. Yeah, just do in the center, I think should be good. I'm thinking about it, 1 second. So in order to be a pivot in the center, you're able to do this function right here, which is $CEV. Well, this is actually CS, I don't remember right now, but let's see. Let me just unlock it so you can see. Yeah. So what this does is it's gonna center the world, the pivot, right, wherever the Y of the object is. Okay, and I'm gonna put CX and CEZ over here. You are able to, if you already have this when you're pressed, and you're able to create this and say override by default. So you're able to have that functionality always in the same node. So or you can do a save as a preset. For example, I want to do a center pivot right here. Save preset. So as soon as you go back right here, you're gonna have center pivot right there. So just a heads up, because a lot of people, I reinstalled Houdini recently and I didn't have all my stuff together. So I will totally do that to avoid issues later. All right. And then we want as well a little bit less of the thickness. Let's do yeah, perhaps like this is fine. All right, and then oh yeah, I did the thing, but I didn't even scale. So what I wanted to do here is I want to scale on the y-axis a little tad. Okay. And just keep checking, see how that works on the back of the subnetwork. So I'm gonna lock it again. Now I'm gonna be able to go back in, and let's scale that up a little bit. And now I'm able to move my object however I want and see where I exactly want it to be placed. So it needs to be a little bit in the back, and you can see that it rotates a little bit outwards, I believe, outside. So we're gonna do that as well. So let's just do. I want to make sure that I rotate on the z-axis. Yeah. No, not on the z. Sorry, the x. And we are able to just move and translate however you want right here, because it will just do the job. I don't know why I'm not able to see the gizmos here, but anyhow, if anyone knows the solution, I would love to know how to do that. Alright, perfect. I'm going too much into the details here, but you guys get the point. Now, let's go back to our object. And I believe that we can start today just by going to the VDB side, guys. I know you guys are probably like tired of seeing a lot of little details that, and we can like see some VDB action today. Is that what you guys want to see or no? Please let me know. Drop a comment. I'm waiting. Or people are gonna be like bored as hell seeing basic stuff that don't. It just takes time. Yeah, okay, no one commented. That's fine. So I'm gonna go and start creating the subdivision for other things, and we're gonna get to the VDB side of things. Okay, so we know that we have this, so I'm gonna start naming some graphs here, so just so we can have an understanding of each shape, right? And this is being used for this, which is that. Okay, so we're gonna bring that here. And a beautiful thing about Houdini is you're able to do something quite honestly. It took me a while to learn that, and I loved it. So you have this null node, right? And I'm gonna just say I'm gonna call this node, I don't know, cylinder, whatever. And I'm able to lock this down. Okay, so if I lock this and I take it off, it saves, it freezes whatever the information is there. So I'm able to just do this, and it will follow through the chain, which is fantastic because I have, you see it, I have plenty of different like it's getting like plenty of different graphs, right? This one is actually fine because it's in the middle. And actually, I would change this. I would actually do another null node over here. I'll just bring that there. And just, you know, delete this. So you have the information, and we're able to just organize into sections of this. I'm gonna make sure that I have all those organized correctly a little bit better because we're gonna start getting to VDB, and I do not want to lose any information. Choo-choo. All right. I'll put this merge right here. I'm gonna delete all of those guys for now because we're gonna go into sections, each one of those. So again, we have sort of the high quality for this already. This is actually good. I would just keep it. We could do the subdivision as well already, and this seems to be fine. So we have this section which has a merge. We don't need this merge right now, so I'm going to take that off. Let's see this one. This is the top part of the little ring. So we don't have a subdivision for this yet, so I'm going to make sure that we have. So I'm going to put a subdivide and just use. Actually, no, I'm going to put some edge loops right here because we might need it. So just choo-choo. Polygons. What the hell is going on here? No, polymoly. And I'm going to add edge loops into the whole thing. You can press Q in your keyboard, and it will just it will do the work for you in order to get the division. It will repeat this last action that you did. I believe there is a way that you are able to. Yeah, you can do like more loops, as you can see right here. Okay, and there's also a possibility of you. I don't know if it creates polysplit creates the polysplit, but you have to select which edge you want, right? you are able to bring all these guys into one for each loop, and it will just do automatically for you. So I actually, in the past, I created a tool, I don't have it anymore, that you're able to subdivide just by the edge loop and not by, like, for example, I don't want the X and Y of the face to be subdivided, that kind of thing. So you select kind of like the coordinate of what you want, and it will do subdivision for you. So let's just do 2 for each one of those. Just select all of those guys. Again, another beauty of Houdini is that you're able to select all the nodes and just does the job for you. And just put 2 over here. There you go. Perfect. And now I'm able to subdivide. And what I have the subdivide. I want to override the creasing. There you go. I'm gonna put it a little bit more. Now, okay, let's just check the reference so we can see what it does. Yeah, it doesn't seem to have any sort of a fanciness over this piece, so I'm just gonna leave it that way, I guess. It seems to me that it has a little more thickness, though. It seems a little more thicker inside. Okay, so just do that. Oh, it seems fine. But one thing is, we're using the distance right here, right, as in order to extrude, and that may be bad because we want to make sure that, let me put this as, we need to transform this into global and scale down a little bit. So I'm gonna actually scale just the X and Y. So I'm gonna bring that, copy and paste right here, okay, and I'm gonna use the scale right here down. And then now I'm able to just put this to 0 because we want it to be flat. So that's the way I would do it. Bam. Okay, that's good. And then we want to have the little lip on the bottom. So I'm gonna just make sure I do some sort of cleaning here. Put a subnetwork. Save the file. I'm gonna add a edge loop. Just this is not like necessary, but I find it that little details like that is gonna pop whenever we put on the high poly. Put another edge loop. And I'm gonna select all the faces that are surrounding this area. So in order to do that, you're gonna press 8 on your keyboard. Okay, and then press middle mouse button on the section that you want, and that will cause it to go. If you wanted to select just a row or until a limit, you just press A and then click with the left mouse button. That's pretty much the idea. It doesn't work the same way as mine, like where you select the other face. Now you have to press A and then middle mouse button, and we'll select the whole section. Now I want to scale this guy a little up. Not much. Or you can actually peak it. So in order to peak it, you're able to do, let me see, peak handle. I think it's H. Yeah, you press H on your keyboard and it will do the job for you. There you go. That's kind of the idea. All right, now that we have this, let's check the other section. Let's see the reference. Seems fine to me. Yeah, seems okay. And then let's just check this one as well. Okay, and this one. Okay, so now we need just subdivision for those guys. There's nothing else that we need to do here. So I'm gonna add subdivision. We already had it before, and it's doing this bad job right here. So I'm gonna try to see what's going on. Seems to me that was supposed to do the right work, but I think the fuse itself is too large, so we're gonna have to put a like super small amount of fuse, and there you go. But it's not merging some points here and there. I don't know why. Let's see if yeah. Okay, that seems to be okay. I think it's just a it's just the normals, it seems. Let me just check and see if I have the open edges. Yeah, I don't see any blue lines. So the blue lines are supposed to show where the edges are open. So this seems to be good. Or we can just diminish the amount of subdivisions because we're gonna go VDB anyway, right? And you're not going to notice that stuff. Definitely not. It's never going to show. All right, so now we're gonna bring this guy, which is that, and let's subdivide this as well. I hope you guys are following me. If there's anything that I'm missing or you guys want to see again, or please let me know. I'm gonna create a crease right here. I'm also like super sleep deprived. I'm trying my best here. All right, so then we want to select edges that are that we want the crease to do the job. So I'm gonna press go on the crease over here. I select all the edges that we want to be creased, or chamfered, whatever you guys want to call. But we want to do this before, yeah, let's do that. We want to do this before the copy, to be honest with you guys, because we want to make sure that we have everything correct. We can do a group here. I think it should, yeah, we should probably do a group and do a by angle. It's much better in case we need to change anything later anyway. I'll put this crease. Yeah, that seems to be fine. And the crease, I'm gonna put the crease group, crease 4, which is the name of the group node, and then put this as like way larger. Why is this not working? Well, yeah, I don't want to overwrite. So there you go. Now we have a little bit more subdivision there. I'm gonna put a little bit more. There you go. Put copy, perfect, and put a normal as well. Yeah, I'm gonna bring this to be actually by face as default. I'm gonna override my settings because you really save as permanent defaults. Because honestly, I never use vertex normal as much. Usually I can use it, but at the end of the day, I will use the vertex split after the fact because I want to see S points, and every engine will actually read those verts as points in a better way for the normal side of things, which the node that I'm talking about. So for example, if I have this right here, and you can see that the normals are vertices right now. It's not it's vertex based, not points. So as soon as I do a vertex split right here, and I'm gonna bring that guy, and I'm gonna make sure that I have this as normal. And if I promote it, let me see if I have any normals. No, I don't. So I have to create a normal node here. It's actually important to understand, guys, because a lot of people have problems when, I think they fixed it already, but a lot of people have problems whenever they have the vertices like this being open, right? And you have an angle. What this does is it's going to cause you to, every single vertex is, that is separate from the other normal, like a hard edge, for example. It will split. It's just that the softwares that we use are pretty much lying to us that it doesn't split. So your engine will pretty much see S2 verts right there. There's nothing that you can do. So especially that if you bring a point right here, right, it's open. See? So it's something that I had issues before, like whenever you was sent to Unity or even Unreal, and I never knew why was this happening. Is because I needed to use the promote to point attribute. So now that we see this right here, we see that we have a vertex attribute right here, which is normal. And as soon as we go here, it just converts, it promotes the parameter to be points. That's pretty much what I wanted to show. We don't need to see this now because we're going to change it to VDB anyway. Anyway, okay, cool. Now let's check the next section. Almost there, guys. To the VDB. This is simple. We don't even need to bother about this. We're gonna leave it the way it is, and the top part. Okay, so we just need one section to be a little bit more subdivided. So let's do a crease group 10. And again, I'm just doing by hand because I could bring the group, but I think there's some angles over here that it would not do the right job. Okay, I got it. Everything apparently? Yes. One more here. Yeah, okay, cool. So now we have decrease. I'm gonna do subdivide. Put this to 2. Okay. Yay, cool. And I think we're done. Let's see. Yeah, I think we're done. So now we will transform every single object to VDB. So how do we do this? If you've never messed around with VDB, it's quite interesting. It pretty much transforms everything that you have, whatever surface you have, into voxels. Two things that we need to make sure to do not leave anything open. Like it has to have solid. Thank you, Evening. Appreciate the feedback, man. You have to have everything solid, right? So even if you have to like force it, do a fill node, right, and fill the node in order to actually not have anything open. It's extremely important because it's not gonna work. Okay. So I would advise that. I'm not seeing anything that is blue, so I'm fine not using it. I know I'm secured by doing that, but if you're not used to it, I would advise to do that per se. So I want to use the VDB from polygons, okay? And do that. It's gonna be very small, so we're gonna have to make sure that that number over here is very correct. And you can see that it looks like Minecraft right there. And usually we start seeing that basically it's like the surface over here on how he's reading is actually tiny little sprites. That's pretty much what he's reading, but the math behind it is not what it's showing, right? So it's just the way that Houdini interprets and shows volume, which is basically creating a volume right there. And you want to make sure that you feel the interior of that. You do not want to leave it open because there's reasons why you actually you are able to leave it open because you can create some sort of thickness, especially for 3D printing. It's really cool that they give you that option. So just letting you guys know. Alright, so now we have the VDB to polygons right here. I'm gonna bring for every single section. But before I do this, I want to create sort of like a null. No, actually, you know what I'm gonna do? I'm gonna bring every single one of them into subnetworks. Much easier and clearer. I think there's a hotkey. Let me see. Shift C. Alright. So now that I have this, I'm gonna press. Actually, there's a way of doing this by. You can go here on the layout, align nodes horizontally. There you go. And then distribute nodes horizontally. There you go. So that just makes it easier. Perfect. So now we will bring VDB to everything. I like it to do it separately, guys. You could do together. Well, actually, we'll test it first. We need to make sure that if I'm doing the right thing here in order to... there's some things that you may want to do it separately and some things you might want to do it together. So just keep playing with it and see how it goes. Alright, so now I merge all of those guys together. Let's see. Alright, now we have this, and you can see we're already having some issues here and there. There's some stuff flying, and we need to find out what is causing the issue, right? It might be that one of them is open, so we're gonna have to go and check each one of them. These seem to be fine. Seems to be fine. Yeah, see, like, forgot. There you go. See, like, actually, this one I don't even need, I believe. Let me check. No, I do. That's the bottom. It's just that I was selecting the top right there. So we need to make sure that we have that. Okay, perfect. And then this one. and we forgot the swirl. So one of the reasons why output is important. Whenever you put an output node in, you can see I gave the advice for you guys and I didn't take it myself. Hugo. Alright. I'm gonna bring this ring to be a little bit thicker, to be honest. It seems to be too thin. Where is it? Okay, it's right here. Perhaps 0.04. A little bit more. No, it's fine like that. Fine. Alright, let's go back. Perfect. Let's go back and check everything. Now it's fine. Okay, perfect. We have our whole thing is subdivision VDB. But I can see why actually I might actually need to combine everything together before I use VDB, which actually will make sense because I want to have some of those things that are together. We're gonna use the node VDB reshape, I think, that you're able to create some sort of indents and things like that. So I'm gonna delete all of these right here. I'm gonna take that out. I'm just gonna see with the normals and bring this VDB right here. So you can see that what's causing here is it's bringing, I think there's something open. No, it shouldn't be open. It's bringing all the surface together, right? Sorry, I'm reading 1 second. Houdini and Ultimaker is one cute couple. Oh, you mean the Ultimaker is probably the 3D printing you're talking about, right? I believe so. I don't know names of 3D prints for a long while. Excuse me 1 second, guys. I'll burp. All right, back here. All right, so now we need to make sure that we have a little bit more resolution, I believe, because we're gonna probably need. And let's do 0.03. It's not too heavy. There you go. That seems a little bit better. Yep. And it seems to me that this might need some subdivision, so I'm gonna bring it back to 0.4. I think it's enough. 0.004. And I'm gonna go back there where we have the swirl. I believe that's the guy. And we need to have subdivision on this gentleman right here as well. So I'm gonna bring that here. There you go. That's much better. Because that detail will actually go to the VDB, and we definitely want to see it. Perfect. It's not gonna see you're not gonna be able to see much of the result right here right now because it's all voxel based. But as soon as I put VDB convert and bring that there, I'm gonna save the file because it might be heavy and set it to polygons. It's gonna calculate. And there you go. Now it is actually polygons. As you can see, it is creating all polygonal mesh for us. Okay, so it's actually watertight. It has all of the really interesting edges there, but at the same time, it's a really good thing. You can actually do some blur over there, here and there, just in order to actually manage this. Or you can do like an ISO value. And this ISO value will just kind of smooth it out a little bit, put it like a very small amount. It will kind of blur a little bit of the edges, a tiny little bit, not much, but still helps. See? So it's something to work with. And also, we want to make sure that we have the VDB reshape. So what we can do here is, I think I remember there was a node. Let me think about this. 1 second, guys. Yeah, so I want to make sure that I have VDB, the inverse of that. I'm gonna kind of like bring it out. I'm gonna have to find, where is it? I'm going to use the smooth FCF, so let me just try this first, see how it goes. In order to use this, I'm going to bring the resolution a little higher, down, because I want to make sure that I see things faster. So I'm going to put like 0.008, just so we can work with it, and then we can bring it back later. And I want to VDB, I think it's Boolean, I don't remember now the name, or composite, or it's combine. I don't remember now. Okay, yeah, so what we need to do here is we have this, right? And we know that we have that guy and we have that. And in order for us to, this is why I actually wanted to make separate, but again, we're gonna go the easy route for today because it's already almost the time that I need to go. I've been like doing this for 2 hours, I'm like tired. So I'm gonna do the easier way for today, and whenever I do the next step, I will show the best way. So right now we have mean curvature overflow, and you are able to choose any of those guys, okay? And this gentleman right here, the fifth order, is expensive, but it's good. So as soon as you add more to it, like for example, if I want to trim it, it's gonna try to, there's specific things that we'll do here and there, like you can test your own thing right there, but I would do none for now. And you don't need the fifth order, to be honest. It's such a small little detail, but the iterations, for example, if I put like 10 over here, it's gonna take a long time to calculate sometimes. Depends on how much you have it. And I want, let's see, medium value, let's see. Okay, so you can see that it's trying to smooth the surrounding parts. The problem is we have this surface. I'm going to put a little higher resolution. We want to paint where we want those guys to be, right? Where these cross sections are going to happen, okay? In order to do so, well, we have a way I'm going to show. So I'm going to do a merge right here in between those. And perhaps this, I think. Yeah, that seems to be good. Okay. I don't know if I need on the other ones for now. I'll just do in this one for now, just see how it happens. And I want to make sure that I peak a little bit. I'm gonna peak the normals up a little bit forward. There you go. So because I want this to actually really touch the surface, right? But these normals are in the incorrect direction. So if we go here, we need to make sure that we reverse the normals for which one? This guy. So I'm going to reverse the normal here. And I'm going to peak it again. Perfect. And now there's a thing called intersect analysis or stitch. I don't remember which one, but I'll try. What's going to do is it's going to take a while to calculate because the file is quite high poly. Let me just take the tolerance down a little bit. Yeah, okay, perfect. So what it's doing here is creating points in space where it actually each of the points are actually the points, but if you actually put the output intersection segments, it's whatever it's intersecting, right? It's bringing a curve, which is awesome because now what we can do here, and I'm gonna do a poly wire. And it's gonna be huge for now, but we're gonna bring that down to this, perhaps a little larger. Too much. And I don't want to smooth the points. We don't need it for now. And it's gonna cause this, right? And it's gonna bring that section. Well, I may need the smooth point, but I want perhaps more segments, because I'm getting some issues here and there. I'm trying to find what do I need to do in order to not have that issue. Let me see. Where is it happening? I don't even know why it's intersecting here, so I need to find out. I think it's because of the amount of peak that I'm putting. Yeah, it's intersecting that little part right there, and I do not want this to happen. Okay, so let's go back to our swirl and see what the heck is going on. Yeah, something's going on here, and why, I don't know. It's like that doesn't make any sense. What the hell? Let me try subdivision loop. Yeah, no, it's still doing the same thing. What the heck is going on in there? Let me see. Seems to be fine. Am I blind? Why is he creating a little bump? It doesn't make any sense to me. What the heck? Yeah, so see, there's things that I don't know. Oh, we'll deal with it. It's fine. Put a subdivision by linear, and that should be good. It doesn't do a good job. No, we need to be the other one. It's fine. Let's do a subdivision. It's fine. We'll deal with it. Just not putting a lot of peak. Let's do 0.01. And let's just check the intersection analysis. Perfect. Okay. Polywire. Yeah, so it's gonna do this, unfortunately. There's not much we can avoid. We can try minimizing this by, let me think. Let's fuse some points. There you go. See if this works better. Yeah, okay, so fuse some points in order to actually make sure that we don't have a lot of mess over there on the bottom parts. You can see it will have some here and there, but it's fine. I'm gonna actually do the peak over here a little bit less as well, and see if we're able to get a little bit more of those details. No, don't. It was gonna crash, so let me put it again, the value. Okay, we still have those points, but let's see if I fuse it. Yeah, so if I fuse it, it goes away. And now let's put the polywire. That's fine for now. And this guy, whenever we have this, if we combine, I'm gonna put a polyfill here in any case, and put just single polygon. If we combine those guys and bring it to here, right? You're gonna see we're kind of creating some sort of I don't know, like amendment. I guess I don't know the name of it. I'm from Brazil, so forgive me for my English. Trim. You guys tell me. I don't know. And then what happens here is we are able to change the size of the wire radius. So I'm gonna do 0.01. Maybe that's too much, so I'm gonna put 0.0. I'm gonna leave it 0.02, but I'm gonna bring the peak down a little notch. So there you go. Kind of gives a little bit better approach. And now that we have this, I'm gonna subdivide the polywire. So we know we have more points right there. Okay, and then I'm gonna transfer. Oh, the subdivide node, do you need to choose the creases node under the group? Yeah, so basically if you have, for example, let me see an object that you want to see subdivided. Forgive me. So I created a crease right here, as you can see. right? But this crease is getting the poly bevel itself, right? So what I did was I'm selecting by hand, to be honest with you. It doesn't, I just did it because it was easier. This crease right here, I should not have called that, because I was just literally using this crease for the bevels themselves, okay? But the subdivide node will use something called crease weight, which is this vertex attribute right here, in order to subdivide and leave the creasing happening. That's pretty much the idea. And the crease itself, you're able to bring the amount of crease right here where you have over there. What you can also do, honestly, this actually will be better. I'm sorry I'm coming back to this, but I think it's an interesting subject. I would do a solid over here and do perhaps like 2 sections. Yeah, right there. So you can see that it will actually hold the edges better. Or you can do just the round, right? But instead of round, you just bring the convexity to 0, and it will just have a flatter edge, okay? As you guys can see. Or you can even do like, I don't know, 4, right? Or 5, and do like a ramp. And in this ramp, you can have the profile control right here. And I'm able to control how the bevel will work, which is pretty cool. So I'm gonna go back there. I'm gonna change how I want the bevel to behave. And you're able to say, I don't want you to symmetrize. I actually want you to reverse and symmetrize, sorry. And then, let me see here. What do I want? I want the other ones to be further. Okay, so I need this to be in, no, out, sorry. And then I want to have more points. There you go. So it kind of gives you the control of like being able to, you know, have that more subdivisions in the middle. But there is also, I believe, the curve. I don't know what the curve does though, so I don't remember. I think I have to bring a curve right here. So I don't think it's necessary, so we'll just use the ramp. Okay. Convexity. Yeah, so just as you can see, I'm just trying to pull those faces a little bit more outside, and I'm able to add another point and just bring that inside, and there you go. It just gives a little support edges, and you know, in any case you want to get really like sharpened. I like this control in Houdini. Really do. Like, it gives you a little bit of a ability to just really have like the sharper edges possible right there. So it gives the kind of, they call super specular, right? All right, so now let's go back to our. I hope I responded to your question. REH. Okay, so then we go back to our polyfill, right? It's gonna calculate all the poly wire and everything, and I subdivide this. And as soon as I subdivide this, I'm gonna use something called attribute transfer, and this may be a little bit heavy because we will need to transfer whatever we have in this right here. I put a reverse here, so we need to use the reverse. Okay. And this transfer is going to bring the information and the position of the points of whatever we have here to whatever the object that is here does. Okay, so now I only want to match P attribute. I know it's going to look like crazy like this, but wait a little bit, and I can show you guys what it's going to do. In the transfer attributes right here, you're going to go inside of the conditions, right? And you're going to maximize the sample count, okay? And you're able to do less of the distance threshold and bring the value really down here. So like to very tiny little bit. Maybe this is needs way more sample count. Let me see. I don't think this is gonna work the way I want it right here. 1 second, guys. Why is it not doing a good job? Okay, so maybe we can do another way. Okay, so you're welcome. All right, so let me think about this. Subdivide it. I have that. Okay. So I'm gonna do a color here on this normal, on those guys. The problem is that's happening here is that this doesn't have subdivision enough, and that's probably why it's causing, because actually it's getting to it's trying to ray trace by just the divisions, so we have to have some subdivision on this, and I thought I did. Let's see. Yeah, I just forgot to put it back. Okay, so let's actually subdivide more. There you go. So we have to make sure that we have enough subdivision in order to transfer those that information. Also, this gentleman right here doesn't have enough as well. So let's go back and find which one. Okay, that one seems to be okay. Yeah, it seems to be okay. Well, we're only gonna do one of those ones for today, so I'm just gonna put it where I wanted to. Okay, so I'm gonna add a subdivision right after. There you go. Okay, I think that's enough. And then now let's try it again. It's gonna take a little while because it needs to calculate things there. And now let's see if this works a little bit better. So now let me look at those together. So I'm gonna merge those two. So I'm gonna put a merge. There's different ways that we can do this, by the way, but I'm showing the fastest way right now. Yeah, it's really transferring like super tight over there, so we don't want to be that inside. Let me see if I have. Yeah, so like it's getting very in the interior of it. So what we can do here is, let me think about this, guys. 1 second. Yeah, I have a better solution. So in order to do this, we may have to use or low polys. So we're gonna go back right here inside. Before the subdivide, I'm gonna add two outputs right here. One is the higher subdivision. I'm already gonna. Where am I? Okay. Why am I able to see that? Okay, there you go. I'm gonna add output for low and high. So I'm gonna just call this low. Actually, this is high. And I get another one right here and add low. Okay. We will put the output as the high as the output 1 and the other one as 0. So I'm gonna leave that there. I don't know why it's giving me an error, so I'm gonna try to put 2 and then 0 after. Okay. And then I'm gonna copy that. I'm gonna make sure that just decrease itself, okay, and has a copy over here as well. And I'll bring it to the low. And I'm gonna copy this, because as soon as we move out, we're gonna be able to see that we have the low right here, right? And the high is right here. So we're gonna move the high right here. And I'm gonna do that as well in this low and high. Let me know if you guys are getting exactly what I'm doing here. And I need to do this here. I'm gonna put the reverse inside just in case we need it. It's funny, it is reversed. What the hell? I don't know why it was causing that issue. Anyway, so then put the copy, increase, and then low. Perfect. Yeah, correct. Well, we need to fuse this as well. Bam. Okay. Then why did I need to reverse this? I don't remember now. Okay, perfect. Now we have the peak, right? Oh, I'm getting from the high. Why? Something's wrong. Why am I getting this info right here? This is the low. This is the high. Correct. Then why are you doing this to me? Buddy, I'm getting the low. What is going on? Upward 1, upward 2. Okay, so let's try this then. Oh my god. What the? Oh my god, what's going on here? Upward, yeah, upward 0. I'm gonna try to do something interesting. Put a null to see what is this happening. Why is it doing that? Oh my gosh, that is hilarious. Like, it just, ugh. It is index 1. Yeah, it's right there. Right here, 0. I don't know what's going on. Yeah, I'm putting 0 and 1. I think it's a bug. I don't know. It's just not doing the correct work, I guess. What the hell is this? Oh my god. Alright, I'm gonna redo this high and low right here. I think it's just a bug. I don't know. Okay, perfect. I think this is better. Okay, now I got it. I hope that this works. Yeah, it was a bug. I don't know. It's just, yeah, exactly. I think it just registered the output, but whenever, as soon as I changed it to 2 and brought it to 0, it got lost. So it's probably a bug. Anyhow, okay, got the low. We have the high. All right, so now we know that we have less resolution to play with. We can actually, in order to get the curves, it's going to be a little bit cleaner. So I'm going to do 2. We need to make sure that we have enough thickness, maybe 2.5. And let's test this. See if this works better. Still a little bit annoying there. I'm trying to find out why is this so bad. Okay, let's do a little bit more here. So it's doing the job, but it's not like really good right now, and I think it's because the fact that it's getting confused by the way the normals of the whole thing are doing. What we can do though, there's another forgive me, there's another way that we can approach this. So since we know that we have the high poly for this, let me check. We're gonna do a voodoo thing here, as you mentioned. We're gonna, the poly wire itself, we're gonna bring this to be VDB and come back again, so it kind of cleans the mesh itself. So I'm gonna do VDB from polygons right here, and we can do 0.01. Let's see, a little bit more. Less. Let's do 0.5. Kind of the same resolution as we have on the other one. And then now I am going to be able to convert this. I'm going to convert VDB and bring it to polygons. And I want to make sure that fill interior. Okay. Cool. And now I'm able to use the ISO value a little bit. Should be able to. I don't know why it's caused that, because it's just so small that it will cause the values to just okay, perfect. And now we have a little better mesh to play with, you know. and then we can just send it to transfer and see if that works a little bit better. Let's see. It's not that better, but it's okay. Like, I'm trying the dot away because we're not gonna move forward. See if I bring a little bit more to this. Yeah, okay, it's getting there. You guys can see that how actually it managed to get some of that kind of like the way it is right here is terrible. I know it's awful, but you get the idea of how actually you can actually do that. What you can also do is there's a kernel radius right here, which possibly can fix our problem. Let's see. Let's put this as 50 for now. And then, yeah, so there you go. So it starts to get better. So let's put 0.1. 0.001. There you go. Now we're getting there. Basically, the radius is calculating and letting you know how much you want from each surface to each other, okay? And now we can see that if we put both objects together, it kind of gives you that idea, okay? So that's something to note. If you put 100 on the sampling, because the sample is what actually it matters most, and you can do like 0.001 in order to just get that edge right there. Let's do a 0.02. There you go, starting to get better. Yay. So something like that, right? It will just pretty much give you that what we were looking for, right? In order to get this sort of effect. Over here, I wouldn't use, as you can see, like I wouldn't bother using for this line. So we could just use, we could delete by going to the poly wire right here. Let's see where the divisions are coming to. Oh, okay, so it's pretty much crossing the same intersection. We don't need that. We definitely don't need that. So another cool feature that we can do here is if we add a normal, yeah, in order to fix this, I hope this works, but we'll see. I'm gonna add an order, and I'm gonna make sure that is each vertex equally, okay? Actually, by vertex angle, apologize. And I want to blur the normals. So this way, what happens is it's gonna try to avoid any sort of intersection that we don't want that is in the same object. And I don't want to pinpoint nothing, so I'm gonna put like the value as 50. That should be good. Let's see. So pretty much I'm smoothing out the normals, right? And then whenever I send it to peak, I need to make sure that I don't recompute the normals. This way, it will try to avoid it, because if I didn't have this before, see, like it kind of it's trying to do it, but it's not doing a good job. By whenever I smooth it out, I'm able to even peak more if I wanted to, and have the intersections. Let's see how that works. Yeah, so see, I'm avoiding a lot of other issues and fixing the whole paraphernalia. Okay, so I'm gonna bring this fuse to be less, perhaps 0.01. Bring the poly wire, yay. Convert to VDB. Transfer. And bam, so that does the job. So that's pretty much the idea of what I would do if you guys wanted to like create this. But again, over here, the section that we're seeing here, it's because the fact that, first of all, you don't have, and you see like every single one over there has not enough subdivision, and that's what it's gonna be doing. It's projecting, but at the same time, have you ever tried deleting your user prefs? I think if every time you reopen Houdini, it's probably gonna create one again by default. I don't know. I never did. No. Why is that? Why do you ask? Did you lose it something or? Alright, so I'm gonna choose attribute transfer. Let's do a less kernel radius, see if that fixes. And perhaps a little bit less distance. Or we can just go and do the right work, right? Just go back there and make sure we have enough subdivision on the line itself. So if you go after the refine, we're gonna do a resample. And I'm gonna bring you here. Oh. And let's see if this works. I may have to. Oh no, Houdini, don't crash. No. Nope. Oh. I think it didn't. Ew. Whew. Thank God. Let's see what's going on here. Yeah, too much. We don't need that many, so I'm gonna put 1, 2, perhaps, or 3. Let's see how the refine is there. Okay. Yeah, so we didn't even need the refine, to be honest. But again, we don't want to have a lot of resolution right here, so we're gonna make sure that we manage this better at this time. So it's doing. What am I doing? Oh yeah, I think it's because I scale back down. Yeah. Forgive me. But I want to add this here. Yeah, there you go. There you go. Now we have enough resolution on the vertical areas, and we're able to go back there and check how is this gonna work. But then the low poly might have issues later on as well, so let's see. I think this worked. Yeah, perfect. Yeah, so that gives you that solution for that. And if you want to smooth this out, you're gonna be able to just put a blur if you wanted to, or even like create another VDB and convert again, so you can just bring those guys out again. Oh, sorry, not that way. Duplicate them, bring it back here, and then don't use the ISO value, just put a 0 and blur a little bit just by preserving volume perhaps, or even like just uniform itself, or by edge length. That might keep a little, no, it'll have to be uniform. And then just bring it back, and we need a normal. And there you go. So pretty much that's what I would do in order to have those like little guys. And you can keep playing. You can keep doing a lot of the like playing around with the little fillet, right? I think that's called fillet. And if you wanted to, you can do the connection analysis or whatever you had before, right? You are able to smooth out whatever you have by occlusion as well. So for example, let's just say I have the VDB that I created here, right? Which is this guy. So I'm going to bring it back again. And since I converted, this gentleman, if I can bring, just be careful because it's heavy. I wouldn't do a lot. Let me just do the ISO just regular. I don't want to use the ISO right now. And I want to do the adaptivity by 0.01. So we have a little bit less triangulation. And we are able to create like, or the curvature, or yeah, we can do it by measure. We don't have to do the AO itself. And in this measure, it can be heavy. That's why I'm kind of hesitant of doing this, but we can try. Curvature, CD. So you're gonna see some issues here and there, but again, there's, unless you want to just not use adaptivity, but it might be too heavy. Let's see. No, it's actually fine. We can handle it. So this way, we know now that the curvature, we have the colors for whatever we want to blur, right? The problem is, you need what is, sorry, what is convex and what is not. And we don't have that here. It does by You can do the principle and try. Like I tried many times, it didn't get where what really I wanted. So instead of using the measure, you're able to do there's the curvature of the labs guys that they created the measure curvature, and there's just the ambient occlusion. Put it over here by the labs as well. And this ambient occlusion, it's heavy as well, so you gotta be very save the file before you do anything. Maybe it's gonna take a little while. Or you can reduce the mesh first a little bit, just so you can have a little more room. Okay, there you go. So you can see that even like smaller samples, it's heavy. It's not doing like amazing job. I mean, it's doing good job. It's just that I only have like 50 rays, so that's not good. We don't want to play around with that right now. So what I would try to do as at least if you wanted to have like some sort of different effect for those fillets, there's something that I played around with before. Let me remember how I did it. Oh yeah, okay. We're gonna do 2 VDBs right here. I'm gonna bring this guy to be less resolution, so I'm gonna bring this to 0.2 perhaps. No, a little 1.5. And then convert to polygons. Oops, not there. No, actually I did it before differently, but I can show you this method because I like this one. I actually never tried, but I'm sure that could work. So I'm going to copy those two guys, which is the normals, right, and the peak, the blur for the normals and the peak. Choo-choo. So I blur the normals. I need the normal, of course. And vertex angle. I'm going to use the peak. And I want to make sure that it's really freaking blurred. Maybe not as much, but yeah, I think that's good. And now I'm going to peak that guy. Oops. Okay. Since we peaked that, now I can project that guy back to whatever I had before. And I'm going to show you. We can use rate. And this is really interesting because it's gonna get you kind of like to fake the curvature. I'm gonna use less peak here. We don't need that much. I'm gonna do 0.5. I'm sorry, I'm reading. It was always the suggestion from. Okay, oh, gotcha. Great stuff. Yeah, fillets. That's the job. Yeah. It's funny, like I created a tool for that in the past, but I lost everything, man. I had like tools for every single thing possible. That have been not for every single thing possible, but for things I needed in a daily basis. All right, so now I need to project this geometry into whatever I have here. It's gonna do a bad job because I need the minimum distance. So that's kind of like how I would approach creating fields. See, like now I have the faces, they're getting smooth, but of course because the normal is incorrect right now, right? Forgive me. And now I can actually do another peak after the fact. Okay, so you guys can see how I do it. But I want to do a peak inside, so I'm going to do 0.002 perhaps. Or 0.001, and I want to merge this. Again, this is more global fillet. It wouldn't do you wouldn't be able to do it like for everything. And then I put a normal. Yeah. So that's the idea. Kind of basically, you're creating the fillet itself, right? But in a cheaper way. Kind of faster, but again, you can see that there's some issues here and there, and etc. But it's good to have like options, right? And I think that is a good option. So it's something to think about if you guys want to use that method, guys. I'm gonna be here for a little while, 5 minutes or so. If you guys have questions or anything that you want to comment, or how do you find that useful, please let me know. Because I'm getting super tired, guys. I have to go to bed or relax a little bit. So you see we have both methods, right? We have the one that we created with VDB, and we have the one that we created with just like duplicating the VDB and increasing that. So we can actually even do a subdivide after the fact here, after the array. And don't recompute point normals. Kind of gets some interesting aspects here in there, but again, I wouldn't. How can I say this? I wouldn't do this method all the time, because it doesn't have, like, it doesn't respect some of the boundaries. I mean, the way that the mesh goes, unless you put a lot of resolution to it, which you can. Let me put a little bit less of this guy. Oh man, that's awesome. I'm glad you like it, and I'm glad, I'm happy that I'm being able to help somehow. I know a lot of people are really like depressed and, you know, sad that the COVID is. I mean, I cannot say the word. I'm sorry, but I understand a lot of people are really exhausted of being at home or even like in quarantine. I don't know if you guys are here in the United States or not, but a lot of my friends are really sad, and, you know, everyone is in the whole world. So just protect yourselves and be safe and hang in there. And that's one of the reasons why I'm doing this, in order for to help people, even like improve, even for myself too. So, and I appreciate you guys coming and sharing knowledge as well. Any kind of question you have actually will help me find out a solution. And I may not know the solution, but I'll try to find it. So it's also useful for me. I'm doing this for you guys, but I'm learning. Ireland, nice, dude. That's awesome. That's awesome. Probably very cold right now out there. I don't know. Hope you're safe. I heard things that we're alone together. Sorry. Oh yeah, like I'm single. I live alone. So for me, it's a blessing, to be honest. It's a blessing for me, man. You know. Sometimes it's better to be alone. Right, gentlemen. Any questions, guys? Poke me or message on this video later on, and I'll try to respond. So next step will be for us to finalize with the VDB, or I'm definitely gonna choose this one. I think it looks a little bit better. Okay. And then from there we can do the low poly and texturing. We can probably use Substance Painter or anything related to that. But there's some little things here and there on the concept or the reference that we may, you know, be able to add, and I definitely want to, because I think that, you know, it's a good object to go to portfolio or something. So I'm gonna read here. Kind of spring like here. Yeah, I don't mind being alone. Yeah, I know, right? A lot of people have kids and have, well, they're having a hard time, man. It's rough. I can't imagine. I never had kids, but I was married for 11 years, so I know what it is to be at home, and, you know, people are people. Like, it's not anyone's fault. It's just that it's good to actually get out of the house and go to work and do something. If you're in a couple or you live like a, you know. But again, I'm pretty much trying to do this to support and bring some inspiration for people that find themselves like stuck, you know, or anything. Anything I can do to actually give this attention. So, you too, my man. Thank you. Appreciate. I don't know. You said evening, but I don't know if you're a girl or a guy. So, no matter what, stay safe, and hope I see you on the next video. Thank you so much for watching, guys. Hope you guys have a wonderful day or night or wherever you are. Thank you. Take care. Oh, thank you, man. I mean, I'm that's what I'm trying to do as much as I can. So anytime, ask me, and I'll try to do whatever I can.